Science and Practice. Once again, I am Dr. Tadeo Kahigwa Tivasima, lecturer at Mountains of the Moon University in the Faculty of Agriculture. In our last session, we talked about some of the principles of agroecology, and today we continue with the principle on political dimensions of agroecology. Under this principle, agroecology prioritizes the needs and interests of small-scale food producers who supply the majority of the world's food, and it de-emphasizes the interests of large industrial food and agricultural systems, as we know that they are corporate companies who look at the production of food, especially from the economic perspective. So with agroecology, it is looking at bringing on the table the issues of the smallholder farmers who are producing health and safe food and are producing most of the food that is consumed world over, as opposed to the large-scale farmers who are more oriented at participating in the production of food for profit. And also in the end, you find that most of them are looking at production of medicine to treat some of the diseases that are caused by the wrong food that they have fed to the people, the non-communicable diseases. Now, in the political dimension, agroecology puts control of seed, biodiversity, land and territories, water, knowledge, and the common into the hands of the people who are part of the food system, and so achieves better integrated resource management. So more participatory approaches towards the management of resources than listening to only the large-scale commercial companies that may not look much into, for example, how do we ensure that a local swamp is sustained because of the roles it plays in the production and sustainability of the food system. So agroecology brings at the forefront the voices of the local people, and therefore is encouraging participatory resource management. Agroecology looks into changing power relationships by encouraging greater participation of food producers and consumers in decision-making on food systems, and offers new governance structures. So it looks into policy revisions that will enable the participation of the local people in determining what they produce and what they consume, as opposed to corporate companies such as Syngenta, Monsanto, those that are more into the production of seed, accompanying it with other inputs like fertilizer, herbicides and pesticides for profit maximization. Agroecology would like to rather focus on the local production systems and ensuring that the local people are a part of the decision making than dictated by large and rich corporate companies. Politically, there is a requirement of a set of supportive complementary public policies that will enable the smallholder farmers to exercise their full potential. Encourage social organizations, decentralizing governance and local adaptive management of food and agriculture systems, and incentivize self-organization and collective management of groups and networks at different levels, from local to global, such as farmer organizations, consumers, research organizations, academic institutions. By empowering these agroecologically, we enable the adoption of more sustainable production systems. Now, I invite you to some of the key agroecological systems that are more in line with the agroecological approach towards the production of food, feed, and fiber. In these, as I earlier on mentioned, we do not necessarily look into new or scientific perspectives that are rocket science, but we build on existing knowledge in integrated pest management, in integrated crop farm management, permaculture, conservation agriculture, organic farming, agroforestry, as foundations for integrating new perspectives by bringing into play the 10 elements and the principles of agroecology, so that we can make more functional these systems, more robust and more holistic, such that they can contribute towards the attainment of the economic, the social, and ecological sustainability of production systems. So with integrated pest management, this is particularly a careful application of all available pest control techniques and subsequent integration of appropriate measures. And for agroecology, we do not look at magic bullets to challenges. We therefore look at the holistic implications of any occurrence on the farm, and this will determine our intervention. If a pest is still on tolerable levels, it does not require application of a pesticide using very high concentration levels and very subsequent application, but rather look at the alternatives that can manage such a pest below economic loss. Integrated pest management as a system effectively eliminates pest populations while at the same time preventing death of beneficial organisms. So it will not, as I mentioned earlier, look only at the pest as the only problem of the farm, but would rather look into, after solving this issue of the pest, what are the likely consequences of the solution that we have used? How about the beneficial organisms? How do we ensure that they are not killed alongside the pest? So a successful integrated pest management strategy requires a detailed understanding of the population ecology of the pest, as only with this knowledge it is possible to make decisions about which pest control measures are appropriate and when to apply them. Understanding the population ecology of the pest and its relationship with environmental factors allows action thresholds to be set, which are the point at which control is required in order to minimize the potential economic damage caused, as I earlier on explained. Integrated pest management strategies can be expensive to develop and require engaged management of the agro ecosystem. In contrast to conventional management, careful monitoring ensures that pesticides are applied at the point when they are likely to be most effective and when they are actually most needed. This approach reduces total pesticide use, hence reducing the development of pesticide resistance. We know that when you continuously apply a certain pesticide at a certain concentration, super pests can develop and they will not be affected by such a pesticide, therefore requiring more concentrations of the particular pesticides. So only not a continuous application of a pesticide is very effective in control of a pest, but actually a manipulation of these strategies can be more effective in controlling a particular pest, as it has been mentioned as it is one of the key driving factors for conventional or heavy reliance on synthetic pesticides. The other system is integrated crop or integrated farm management. In this system, the management of farm production in a way maintains and enhances the environment for wildlife, people, and at the same time produce economic yields of high yielding and high quality crops. Integrated farming seeks to optimize the use of inputs by combining cultural, biological, physical, and chemical techniques. So here we are looking at how can the different enterprises support one another, and we minimize the use of synthetic or external farm applications. This system builds on also the concepts of integrated pest management, but it takes a more holistic approach to crop management than integrated pest management. So instead of waiting to solve a challenge of the pest, integrated crop management will look into ensuring we are planting the appropriate crop in the appropriate ecological zone. We are using the most tolerant variety, and we are also implementing other agronomic practices that will result into management of some of the constraints that would eventually result into pest and disease outbreaks. Another system is permaculture, which is an ethical design approach rooted in observation of natural systems that can act as a framework for creating productive landscapes for human needs. It integrates human needs and ecological processes through systems designed to mimic natural processes, and it incorporates a range of disciplines beyond agriculture. So how humans can actually live within a farming system and design it according to the local landscape, but also integrate, for example, the homestead into the farming system and fit within as a part or element that is within the production system. Some of the disciplines that are included in permaculture that are beyond the agriculture of conventional production systems include that when we are designing the farm, we look at the landscape, we look at the architecture issues, we look at the community development and the plans for developing the entire community. We look at energy production and storage. We look at land management issues, economic and legal systems. All these are entailed in permaculture and are beyond the normal agriculture, which looks into only the production and enhancing productivity of a particular crop. Permaculture has three ethics: the care for the earth, which deals with the living soil, environmental stewardship, care for the people, which recognizes humans as part of natural systems, thus seeking into improving both human and environmental health, care of returns the fair share, which recognizes the importance of resource productivity and distribution and the interaction of consumption practices. This builds into the element that we discussed earlier on, that is looking into solidarity economy, but also is looking into efficiency. This agroecosystem seeks to benefit all life forms, including humans, wildlife, plants, fungi, and microorganisms. So in a way, permaculture is very close to the aspect of ecological sustainability as applied in agroecology. In our next session, we shall be looking at other systems of agroecology. We have looked at integrated pest management, we have looked at permaculture, and these are key foundations into which we can integrate the principles and the elements of agroecology to advance into a more sustainable agricultural production system. Thank you for participating in this session, our 5th session on agroecology, science and practice, and I look forward to having you in our next session, where we are continuing with the agricultural production systems that relate and integrate into agroecological farming approaches.